So we are discussing the next assignment of week 10 for the course of operation and planning of power distribution system. So the first question was asked, like the optimization of distribution system involving expansion planning needs, means we are dealing with the expansion considers both feeder routes and branch conductor sizes. So the answer is C, determination of both optimal feeder routes and branch conductor sizes. Now second, which of the following can be the objectives in the distribution network reconfiguration problem? So for the reconfiguration, we require maximization of service restoration and PV hosting capacity. First option is right. Second is minimization of energy losses, means we are reducing the energy losses. So these two options are correct. Third is maximization of switching operation. Switching operation cannot be maximized or minimized because we require the minimum amount of switching operations to be done during the operation of whole day. Maximization of substation capacity. Substation capacity is fixed once it is installed. So the first two options are correct, maximization of service restoration and PV hosting capacity, and second is minimization of energy losses. So these two options are correct according to me. Third is, which of the following are not the constraint in distribution network reconfiguration? So first is thermal limits of the distribution line, that is naturally the main constraint of the reconfiguration. Network radiality, that means we always portray that the network should be radial. Third is the node voltage is within the specified limit variation, that is minimum or maximum tolerances. So minimization switching operations, that is third option, is not correct. So it is not the constraint in distribution network reconfiguration. So answer is 3. Now fourth, Pareto based multi-objective optimization can be used to. First is it is used to provide the set of non-dominated solutions, that we have already drawn the graph, that objective function 1 and objective function 2 on this x and y plane, two-dimensional problem. So we have solved it and we have found out the Pareto based non-dominated solutions. So first option is right. Second, can be used to solve problems with only continuous decision variables. It is not true, it can used with the discrete decision variables as well. Third is, for static as well as dynamic planning problems, this Pareto based multi-objective optimization can be used, but it will give a set of global optimal solutions. So it is a slight controversial or say contradictory statement, so we cannot take it as the correct answer. Now last is to solve distribution network reconfiguration problem with multiple objectives. So it is right. So option 1 and 4 are correct. In inertia weight particle swarm optimization, IWPSO variant, and inertia weight is multiplied with the velocity just to make the balance between local and global surge. That is the objective. So answer D is right. The expansion planning of a distribution network involving cost and reliability needs to be carried out using Pareto based optimization approach to provide non-dominating solution set of conflicting variables or objectives that we have seen with x square and x minus 2 whole square, that we have already gone through while doing the exercise or when the course coordinator had taught us with the example. Which of the following is correct about the dynamic programming? The dynamic programming is suffered from the curse of dimensionality in case of very large number of objective dimensions or optimization functions. So dynamic programming may not be computationally efficient and suitable for optimizations with considerably large number of variables due to the curse of dimensionality. So option D is correct. Now eighth, which of the following is true about CLLI? So maximum value of CLLI represents or correspond to minimum reliability of the network. So option 2 is right. And maximum value of CLLI is affected by the number and location of sectionalizing and tie line switches in the given network. So option 2 and 3 are correct. Now 9, the planning approach for the determination of number and locations of sectionalizing switches needs the objective function formulation which considered only both minimization of total installation or commissioning cost and maximization of reliability. So answer D is correct. With increase in the number of sectionalizing switches in a given network, just we are reducing or decreasing the value of CLLI, means improving the reliability of a single feeder network as well as multiple feeder network. So option 1 is correct. Now I am submitting the answer. So this is done. Your answer are successfully submitted. So this is